Hey folks, let's turn to page 11. We're going to work on pages 11 and 12 today, diffusion and effusion. Okay, the words sound alike, but they're a lot different. So it's a hot, let's imagine it's a hot day and you get on the bus to go somewhere and all of a sudden you smell somebody's perfume. Ooh, the molecules get to your nose. What's happening is you are experiencing the diffusion of gases. So the gradual mixing of two or more gases due to random mixing. Okay, so it's like perfume and body odor on a school bus. That's diffusion. Okay? If you've ever had a balloon, right, and you know that there's a little hole in that balloon, effusion is the random motion of particles confined in a container when they go through a small hole. So when you're getting air coming through a hole in your balloon, that's effusion. Okay, so for myself, I always put the perfume in the balloon so I know. Well, gases move depending on their molar masses. Okay, so we're going to use capital MM for molar mass, and I can look at the kinetic energy of gas A as being one gas and the kinetic energy of gas B, and we've got an equation here. Okay, so the rate of gas A over the rate of gas B equals the square root of the molar mass of B over the square root of the molar mass of A. So notice that they're opposites of each other, right? I highlighted that there. Okay, so we're going to do a couple problems together and then you guys get to work on these yourselves. So we're going to work at number 1. Okay, so I've got hydrogen. Now hydrogen gas, I need to remember my diatomics is H2. Carbon dioxide, CO2. Okay, so I want the rate. It says how many times faster is H2? So my rate of H2 is going to be on the top over the rate of CO2. And then I'm going to do the square root of the molar mass. Now look up the equation, right? H2 is on the top, so its molar mass is on the bottom. The molar mass of CO2 is on the bottom, so this is the molar mass of CO2 on the top. So for this first one, I'm writing a lot out here. Okay? Now I need my molar masses, right? Molar mass hasn't gone away. So one hydrogen is 1.01, so this is going to be 2.02 grams per mole. Okay, that's my molar mass. Carbon dioxide is 1 carbon and 2 oxygens, and that's going to give me 44.01 grams per mole. Okay. So the square root of 44.01 divided by the square root of 2.02. So how many times faster is hydrogen, H2, compared to CO2? When I take this, I'm going to take the square root of 44.01 divided by the square root of 2.02. I am going to get 4.67. So that is saying that hydrogen moves 4.6 times faster than CO2. So sorry I wrote that a little bit big in there for you. Okay, so if they're asking how many times faster, right, I'm comparing the rates. So that was number 1 on page 11. All right, I'm going to do number 3 on page 11. Uh-oh, I've got an unknown gas. So I don't know what that gas is, and I have helium. So my unknown gas is diffusing 0.25 times faster than helium. Well, that's kind of funny. That's not really faster. It's got to be slower, okay? So we're going to put my rate of my unknown over my rate of He, helium, okay? So that's what my first sentence says, but they want to know my molar mass of my unknown. So I'm going to use the rest of this equation. Okay, so let's plug some numbers in here. I know I'm writing a lot out in a small space. Okay, so the molar mass of helium, I am going to end up going into space 2 a little bit here, ladies and gentlemen. Okay, I'm writing really big. So 0.25 is going to equal the square root of 4 over the square root of x. Okay, so I'm just going from here, and I'm going right up here because I ran out of room. Now, square root of x, that's giving me the creepies. How can I get rid of square roots? I hope you're saying, hey, let's square the whole thing. Okay, so when I square the whole thing, I'm going to get 0.0625 equals 4 over x. So my x, my unknown gas, is going to have a molar mass of 64.64 grams per mole. Okay? So I apologize that this is, both of these are number 3. Okay? So I took from here, my unknown gas is 0.25 times as fast. So I put him on the top over helium on the bottom. I use my equation to have the molar mass of helium diagonal, okay? My molar mass of helium divided by my molar mass of unknown. I squared the whole thing, and I ended up with that, okay? All right, let's go to one more. We're gonna go to page 12, and we're gonna do number 6. Page 12, number 6. All right, so my rate of argon, AR, over the rate of hydrogen, and hydrogen is H2, okay? And they want to know, they're telling me the rate of argon, so this is 3.56. Oh, I don't know the rate of hydrogen, but I have that equation, right? I have the molar mass. This is the molar mass of hydrogen. I'm going to put H2 up here in the corner. And the molar mass of argon is 39.95. So I can do the math here. I'm going to get 3.56 over x equals 0.224. And then I'm going to get x equals 15.89 milliliters per minute. Okay, so this is the speed of helium. Oops, of H2, pardon me. Okay, and hopefully that makes sense, right? Argon has a molar mass of 39.95, and he goes 3.56 milliliters per minute. Helium is a lot lighter. He should go a lot faster, and he's fast at 15.89 milliliters per minute. All right, you guys get to try the rest of 11 and 12.
Okay, guys, this was Red TV reminding you that chem is try.